In a few mills we have seen, we have noticed, even the standby compressor is working. That means you can imagine what is the amount of leakage. नमस्ते, मैं हूं गिरी शर्मा। आप देख रहे हैं स्पिन केयर चैनल, इंडिया का एक्सक्लूसिव टेक्सटाइल इंफॉर्मेशन चैनल। आज के संस्करण में आप सबका स्वागत है। सत श्री अकाल, वणकम, वेलकम। आज का विषय है कंप्रेसर एयर लीक ऑडिट, यानी कि सेव 30% कंप्रेस्ड एयर थ्रू एयर ऑडिट्स। चलिए, विषय चालू करने से पहले आपको बताना चाहता हूं, ये YouTube वीडियो के नीचे चैनल की नाम दिखेगा स्पिन केयर। अभी तक जो भी सब्सक्राइब नहीं किया है, मेरा निवेदन है झट से सब्सक्राइब कीजिए। लाइक बटन प्रेस करना ना भूलिए। जरूर शेयर कीजिए आपकी दोस्त लोगों के साथ, क्योंकि बहुत ही अच्छा इन्फॉर्मेशन है। एंड बेल आइकॉन दबाना मत भूलिए, क्योंकि आपको जब भी हम नया वीडियो अपलोड करते हैं आपको नोटिफिकेशन तुरंत मिलेगा। So our Spin Care channel, if you have so far not subscribed, this is a humble request to you to please subscribe to our channel, press the like button, and do share this valuable information with your colleagues and friends in the industry. And do not forget to press the bell icon, because you will get notification whenever we upload a new video. This episode is sponsored by Virat Engineering Solutions, Guntur, Andhra Pradesh. Engineer A.B.Y.N. Swami is the founder of Virat Engineering Solutions, and he is a subject matter expert in the field of compressor and air leak audits, thermography audits, energy conservation. They also have a state-of-the-art laboratory in Guntur where they provide servicing of pneumatic cylinders, solenoid valves, etc. We thank Mr. Swami and Virat Engineering Solutions for sponsoring this episode and giving their valuable inputs. Do you know only 50% of the compressed air goes to production? आपको पता है? Only 50% of the compressed air that you generate is used in production machinery. This is a very interesting slide. This is an international survey of the entire globe. All the compressor users, all industries, a detailed survey was conducted, and this slide gives you a very interesting data. The total compressed air production, you use only 50% for the production machinery. The rest 50% is a wastage. If you look at it, 25 to 30% of the compressed air is wasted in the form of leakages. 10 to 15% is artificial demand, and 5 to 10% is inappropriate use. So there is a lot of potential to save compressed air. And this data does not belong to a spinning mill or an Indian data. It's a global data, be it spinning, textile, or any industry. They have found that in all the industries, all kinds of industries, wherever compressor is in use, it is roughly 50% is wasted, only 50% is utilized by the production machinery. In India, we have conducted a lot of compressor air audits. We have conducted a lot of air leak audits, and our findings also say the same. Minimum 25 to 45-50% leakages we have found in different mills, even the best of the best mills, which follow all the systems, audits, and everything, ISO. Even After stringent care, they are also losing 20 to 25% of compressed air as wastage due to leaks and inappropriate use. Air leaks accounts for the largest demand in your plant. You have to stop it. You cannot afford such wastage. We need to stop air leaks by identifying them and by doing periodic audits from time to time. So it's time we stop air leakages. See, we should recognize some facts. Manufacturing business is under stress to deliver more value for less cost. With increased competition due to globalization, it is more important than ever to ensure competitiveness. Energy prices will continue to rise. We have to identify leaking emissions and help restore the production plant to peak efficiency. Power consumed in producing compressed air will impact the competitiveness of the production units. Inefficiencies in compressed air system typically account for up to 30% of energy waste in a spinning mill. Practically those hidden leaks that cannot be heard or seen by naked eyes. So what should we do? This is where air audit comes into picture. We have to conduct compressor audits and air leak audits periodically, because in spinning industry or in any industry there is continuous rotating load, and it is the machines are working 24 into 7, 365 days. What happens even if you arrest the leaks, correct the leakage issues, still within 6 months new leaks can start, and apart from new leaks, the existing leaks that you have repaired can also start leaking again. So, how to conduct an air audit? What instruments are required? Air audit tools, special instruments required to carry out the audit. To carry out air audit, first and foremost thing that you require is a flow meter. So the mill should have a flow meter, or it can ask anyone who is providing these services. They will bring this flow meter. This flow meter has to be attached to each and every individual machine, and we have to check the airflow in CFM in stopped condition. So why in stopped condition? Practically in stopped condition there should be no consumption. The compressed air consumption has to be zero. And when you connect the airflow meter and stop the machine, after that, if there is any airflow, that means there is a leakage in that particular machine. And you can measure with the airflow meter what is the quantity of CFM that is being lost per minute. Air leak audits should be carried out starting from the compressor room. You have to check for air leakages. All the compressors, dryers, filters, main header line joints, branch pipeline joints, machine incomer valves, PU tube joints, pneumatic cylinders, solenoid valves, etc. We conducted a compressed air audit in one of the leading mills in Western India, and the audit findings we want to present, we cannot disclose the client's name, it's confidential, but we are presenting you the data so that you will have an understanding of what can be achieved by doing an audit. This is one of the best mills, fantastic mills. They follow all maintenance practices, good work practices. They even check for leakages and try to arrest them from time to time. And even in this good mill, we could find the potential to save energy. So in the blue room, we found 1.2 CFM being lost. That is, even in stopped condition, the air was leaking and it was 1.2 CFM. And even in working condition also, it will be continuously leaking. So 24 into 7, 24 hours round the clock, 1.2 cubic feet per minute. Just imagine how much compressed air we are losing in blow room department. In carding department, in stopped condition, we found 5.7 CFM being consumed, being wasted basically. So, this is continuously being wasted 5.7 CFM, 24 hours into 5.7 cubic feet per minute. In pre-Kumber draw frame, breaker draw frame, we found 4.5 CFM was being wasted. It was leaking in stopped condition. Similarly, in lap formers, we found 1.2 CFM. In Kumbers, we found 2.9 CFM. In draw frames, finisher draw frame, we noticed 2.4 CFM leakages in stopped condition. In spinning ring frame section, we found 13.6 CFM leakage. It is not actually 13.6, it's much more than that, because we have given a tolerance, we have accepted a tolerance limit of 0.5 CFM per mission, per ring frame, it will leak. We have taken it for granted, we have given a tolerance. And if you add the tolerance, it will be much more than that. Okay. But still, after the tolerance, still we are losing 13.6 cubic feet per minute. In autoconers, this is the culprit department, we found 34.2 CFM leakage. Here also, it is more than that, but we have given the tolerance of 0.5 CFM per mission. So, after removing the tolerance, it is 34.2. In all, total, it is 63.3 CFM that the mill was losing. So, if we add up, blow room was 1.2 CFM, carding was 5.7 CFM, draw frame pre-Kumber was 4.5 CFM, lap form was 1.2, Kumber 2.9, finisher draw frame 2.4, ring frames 13.6 and autoconer 34.2. Ring frame and autoconers, we were losing a lot of compressed air due to leakages. Total was 63.3 cubic feet per minute. So if you calculate the saving for 63.6 CFM, 1 kilowatt power is required to generate 5.5 CFM. 63 CFM requires 11.45 units power per hour. 11.45 units into 24 hours per day is 275 units per day. That is, 275 units into 30 days is 8250 units per month. Assuming that the unit cost is 7 rupees per unit, then the amount is a staggering 57,750 rupees per month. And for an year, it is 6,93,000. Say round figure 7 lakh rupees per year is too much, and that too this is in a very good mill. So you can imagine mills who never conduct any audits, never bother about leakages, only during some public holiday, that one day they think they can attend to all the leakages. It's next to impossible. Main leakages may be arrested, not every leakage can be arrested. So that way, what happens? Many mills are losing minimum 30% to maximum 40-50%. We have also seen the standby compressors are working continuously. Standby is supposed to be a standby compressor. It should be in stopped condition. It should be started only when any of the main compressors have gone in for maintenance. In that case, we will start the standby compressor. But in a few mills we have noticed even the standby compressor is working. That means you can imagine what is the amount of leakage, what what you just saw was CFM calculation measured with flow meter. So now we know each and every mission how much CFM is being leaking, and total plant how much CFM is leaking. But how do we identify which are the components that is causing the leaks? Because in order to arrest the leak, you have to identify where from it is leaking in that particular mission. And once we arrest it, then only it will become zero. So we need to use the ultrasonic air leak detector to detect the exact leaking components in the mission. The second instrument that you require is ultrasonic leak detector. Why do you require this ultrasonic leak detector? Once you have established the quantity of leakage in a particular mission using flow meter, you should identify which particular component is leaking. You have to pinpoint, only then you can rectify or correct the issue. So, in order to identify, earlier days we used to use soap water solution, which is very tedious and not practical and prone to human error. And sometimes, if it is electrovalves, you cannot use soap water there. Water can damage the electrical components, coil, and other things. So now the issue is there is a lot of noise. All the machines are working. So in this noise, it is not possible or not audible. The leakage sound cannot be heard. You cannot identify the leakage. So the ultrasonic leak detector, it's a very sophisticated instrument. So this will pinpoint where exactly the leakage is. So once you identify that using an ultrasonic leak detector, you have to use tags. You have to tag that particular point so that after the audit, you can return back to all the leaking points and correct them, and once again test them with the ultrasonic leak detector to ensure that there is zero leakage. We conducted this audit, and I want to share a few photographs so that you can understand where all the leakages can happen. It can be in such positions that you may not even imagine, and in the noise of the missions, you will never be able to detect it if you don't have a ultrasonic air detector. So, the first two photographs I am presenting: auto corner number 3, spindle number 29, lifting pipe damage. Auto corner number 2, regulator. From the regulator, it is leaking. Can you imagine? Even from a regulator, it can leak. Then, in the compressor shed, in the main pipeline itself, we found leakage. And in auto corner number 11, air filter connector problem. So you think you have tightened a connector and it is not going to leak. It can leak, and you can identify such leakages only with the help of a ultrasonic air leak detector. Ring frame number 8, Y20, electro leakage. Look at the red arrow. Auto corner number 1, spindle number 9, lifting pipe damaged. Auto corner number 3, cleaning point wall problem. Auto corner number 7, spindle number 7, multi-jet pipe connector. Finisher draw frame RSP D45, solenoid wall set output connectors are leaking. And in blue room separatomat, regulator and solenoid valve is leaking. In Cooper number 3, regulator itself is leaking. In blue room, multi-mixer second chamber piston is leaking. In breaker draw frame number 2, Y4.1 and Y5 solenoid valves are leaking. In compressor 5, the main pipeline joint itself is leaking. In blow room, separatomat regulator incoming input itself is leaking. In Coomer E80, lap lifting push button 3 by 2 way valve is leaking. So these leaks are not so easy to identify without proper instrument. And each leak is going to cost a lot. So it is very important one has to conduct these audits with flow meter as well as ultrasonic air leak detector kit. So when you do this, you can quantify the amount of compressed air being wasted through leakages, and with the help of ultrasonic air leak detector, you can identify and pinpoint the exact location where the leakage is taking place and you can arrest it. So this way one has to conduct the audit. If you don't have the expertise, you can have teams which are doing air leak audits. So Virat Engineering is one of them, Spincare is another one. So you can get in touch with us and we can help you in conducting the audit. We can also train you how to conduct an audit. If you want to procure this equipment, you can regularly do it once in 6 months to ensure that the leakages are bare minimum and you can save the compressed air energy, thereby the power. For air cleaning purpose, wherever possible, air gun has to be used to minimize the wastage of the compressed air. And another issue that we noticed in few mills, the air pipelines is in open loop. The air pipeline should be in closed loop system to avoid pressure drops. We received a complaint from one of the mills that during doffing, the ring frame is stopping, and he asked what is the problem? Is the display giving any message? They said it is stopping and giving a message air pressure low. So we went and we checked, the pressure was dropping, and when at a time 2 or 3 ring frames used to come for doffing, this problem was very pertinent. When we inspected, we found that the air pipelines have not been made in a closed loop arrangement. It was in an open loop arrangement. Once such a thing is there, you will face a lot of problems. The pressure drop issues will be there. And afterwards, the mills made it into a closed loop. And after converting the existing pipeline into a closed loop system, now the air is distributed evenly and there is no pressure drop or pressure loss, and the problem has been solved. So whenever you are designing a new mill, constructing a new mill, or making an expansion, or even in the existing unit, if it is in open loop condition, please make it closed loop so that your machines don't stop for loss of pressure. So what are the benefits of air audit? You can identify air leaks and rectify the same. You can identify inefficiencies in your compressed air system. You can improve the entire system performance. You can optimize your compressor system. You can do effective air management. You can reduce energy consumption and thereby conserve energy. You can reduce energy cost. It will have positive impact on your production cost also. It makes profound impact on your business, not just once, but year after year. As a result of air audit, you will waste less air, you will produce less air because you would have arrested all the leakages. You will reduce the compressed air system load. You will identify leaking machines and help restore the production plant to peak efficiency. You save a lot of money. It reduces compressed air use per unit of production by more than 30%. This has been our experience. So we seriously suggest all the mills to do compressor and air leak audit once in every 6 months. Why 6 months? Whatever you would have fixed can again leak or new leakages can develop. You will be losing a lot of compressed air. So by attending to these leaks periodically, you can arrest the wastage and leakages, and you have to also get in good practices. If the workers are cleaning their clothes at the end of the shift with compressed air, you should stop that practice. They should not do that. And for cleaning points that you are using for cleaning the machines, please ensure that you install a air nozzle gun and you reduce the cleaning pressure to 4 or 4.5 bar. Sometimes in carding it is noticed you require 6 bar, but in all other machines you require only 4 bar, not more than that. And you should avoid using compressed air to clean the floor. While doing housekeeping, we have noticed in some mills people have started using compressed air to clean. It is very costly, it is cutting down into your profits. I hope this episode will help you improve your compressor efficiency, reduce the load on your compressor system, and you can effectively arrest the leaks also. If you have any queries, you can comment in the comment section. We will revert back to you. I hope this will be very useful for all the spinning mills, not just spinning mills, any industry for that matter. And please share this information with your colleagues and friends in the industry so that they can also get advantage of all the information. Thank you.